Hello, my name's Ronald Bartels. I'm from Fusion Broadband, and I'm coming live from our studio in the office at Wichland, Randburg. Now, I just wanted to give you a quick overview on how to troubleshoot a problem at a site in which many people face. So the first thing that a person needs to know is that when you have a site, in any site really, most of the time, it's going to be the internal Wi-Fi that's the problem. How do you detect if it's the internal Wi-Fi that's the problem, and how do you detect whether it's the WAN that's the problem? So I'll give you a quick overview of how we determine whether we've got problems or not, and I'll go right into it by sharing my screen. Okay, so the first thing, I'm looking at our site at this moment in time, and this is the Fusion SD-WAN site. And as you can see, there's usually indications of when we've got packet loss. So 0.41 packet loss, not really a big problem. That often occurs on wireless links, which should never go above 2%. So it's all still fine and good. When we look at it, we can see precisely how much bandwidth is being utilized by the different people, what the actual leg latency is. As you can see here, we've got multiple legs. I mean, we've got a fiber and we've got two wireless links. The one wireless link doesn't have that great a latency. It goes actually quite shockingly high at times to approximately, at this moment in time, nearly 98.7 milliseconds. So what we've got on this particular leg is we've actually got it, as you can see over there, it's in failover mode, and it's actually only a last resort because the latency is so bad on it. However, we've got two links over here that are working quite good. And if we look at them, they are the Bitco fiber link and the Comsol wireless link. And this one is approximately nearly 30 megabits per second, and this one is 20 megabits per second. As you can see, we're just detecting some packet loss on the Bitco fiber link as well, which isn't that irregular in our office park, which has quite a large number of problems because there are quite a large number of businesses around here that have got factories that are using things known as variable drives. So when we go back to it, we go, okay, looks reasonable. What most people do is when they are looking for issues, they go to my broadband and they do a speed test. So here you can see we've got a link that is 30 megabits per second fiber and 20 megabits per second wireless. And what I've just done is I've run an actual speed test, and I'm getting close, nearly, well, 46 and 48 megabits per second out of it. And I'm still doing a live streaming on it. Well, let's test it again, and we have a look. And we can see it climbs up, goes up, 45, 44, quite close, because we're all still using this. You'll notice also that my video isn't breaking up because quality of service is kicking in and preventing it from actually being disturbed. And you'll see on the uplink where we're utilizing it less, we're getting close to 47 megabits per second. So we can actually see that in reality, the link is fine. But what if we were only getting 10 megabits per second? How do we know that the 10 megabits per second wasn't here in my office and that it was actually on the WAN? So what I've installed is a Raspberry Pi. And I just need to bring it up here quickly. Okay, so this is something called open speed test, which I'm running locally in the office. And often we put this on sites. And the reason we've got it is so that you can do a local speed test to something inside the office, not to something at my broadband, which is halfway across Johannesburg. So if we did a test here, this test tests from our PC to the Raspberry Pi that's local. So this is not a great laptop. It's a Lenovo with a Wi-Fi that doesn't really go that well above 100 to 150 megabits per second. But what we see here is what my laptop can do in the office. And what it can do in the office is about 100. So if we were having any problems in the office and we knew that we had 50 megabits per second available out of the office, and we are only seeing 1 megabits or 2 megabits per second or 5 megabits per second locally in the office, then we know that there's a problem on the Wi-Fi in the office. Now, often this is the case because as I move my laptop around and I move away from one location to the next inside the office, I'll go from 100 to 120 to 150. And if I've got a very expensive fancy pants Dell laptop, which some of us in the office have, those guys can get up to 300 megabits per second. So it varies upon, you can test with open speed test what your issues are inside the office before you actually look outside of the office. So that's what I just wanted to show you, plus the ability that what our product does do that nobody else does, is it's got the ability to aggregate bandwidth. And what it means by aggregating bandwidth is, in most cases, when you run a product on anybody else's network, such as the competitors from various places, when they've got a 30 megabits per second fiber and a 20 megabits per second wireless link, they never get more than one of those links' performance. So in most cases, they'll not get more than 30 megabits per second when they do a speed test. So here you can see in our environment, we get way more than what that is, what the competitors do, because what we do is we aggregate those two, and in aggregating those two, we actually have got the ability to actually get more bandwidth. So I hope you have enjoyed that quick little demo of what we're doing, and we'll see you again with the next one.